Meanwhile, this is the data visualization workshop in Python. So we don't expect any background in Python. I am Annajiat. I'm a trainer and instructor from Carpentries.org. And we have with us Intekhabul Hafiz. Intekhab, would you like to introduce yourself?
Yes, I'm Intekhabul Hafiz. You can call me Intekhab or Hafiz, and I'm also a trainer at the Carpentries, trainer and instructor. So I hope we will have a very interactive session today, and looking forward to it. I'm looking forward to learning from you and also to let you know what I know.
Right. Thank you. So first of all, if you have any difficulties at any time, feel free to raise your hand or speak up or type in the chat. It's completely fine. Feel free to ask any question. We are here to learn together. And it might be helpful if you turn on closed captioning, which is free in Zoom. Not sure if this is supported here, but if that option is shown to you, feel free to turn it on so that you see captions. And if you'd like us to repeat anything, we'd be happy to. We'd be happy to repeat anything. So this is we'll go together and we'll try to use something called Google Collapse to reduce setup time. But if you have your local Python installation or other software, you could use that too. So data visualization is an exciting. So a picture is worth 1,000 words, right? So, but starting with a basic of Python, we'll go through different types of visualization. So after we cover some basics of programming, and then uh, there are many other concepts like we need to make the visualization appealing, sometimes well prepared for scientific manuscripts. Sometimes it has to be colorblind friendly, accessible. So we need to take into account many aspects. So we'll try to get started with the Python basics, but anytime if you need any help, feel free to ask. You're not interrupting. It's we welcome all the questions and we learn together. Okay. So how many of us are familiar with Python? Feel free to type in Zoom chat or speak up. Uh, thank you for the reactions. So, Indika, would you like to move to the next slide?
Yes.
Uh, for the ease of following up, we are sharing the link in the chat so that you get to see that link to the data sets and also go back and forth in case we have changed screens. So first environment is the Colab. It uses a free Google account. If you happen to have your personal Gmail account or your organization using Google Workspace, so that is easy to set up. Or you could be using Python and Anaconda or any other compatible notebook systems. We are going to look at some of the packages briefly, which includes pandas, the notebook itself, NumPy, Matplotlib, Plot9. So there are several visualization related libraries. And if necessary, we could install using the last two commands written on this slide. But first, let's download the datasets. So if you click on the service.csv file, it should lead you to the dataset file. I'm also pasting that link in the Zoom chat in case that's helpful. I pasted the same link. This is the surveys. And we have a second file, Boulder Creek. So everyone please download these two files. And the next task to do is opening up Google Colab. The link is here. All right, so as soon as you're done with these, opening up Google Colab and then click on something called New Notebook. New Notebook. Would you like to go to Colab and the new notebook screen maybe?
Okay, so if I reload, you would
Right,
see something like this. And here at the bottom, you will get a new notebook with a plus sign before it. Okay, so if you click on it, your screen, your browser screen would look like this. Okay, Annajiat, over to you.
thank you so much. So we'll be waiting for you to have completed all the three steps, that is downloading two of the files and opening a new notebook in Google Colab. So please let us know as soon as you're done by using the check tick mark green tick. And if anybody needs help, please feel free to speak up, or we can also go into breakout rooms if necessary. Those who join later, uh, the link to the slide is in the Zoom chat. Posting it again. We have the setup instruction on slide number 2. Please download the files and open up Google Colab, a new notebook in Google Colab. It's good to see we're getting the green tick marks. Excellent. If you'd like us to go slower or faster, please do ask. Thank you, Aviva. We got our first question.
Okay.
Well done. Okay, excellent.
So, I'm going to open a new collab. Well, here it came in dark mode, and the other one was in the light mode. But here you would get the new notebook. In case you have skipped this somehow, you have the file option. You have the file menu at the top left of your browser page, and from there you can go to new notebook in Drive and tap on it, and a new notebook will be created. So once again, yours could be dark screen or a lighter screen. That depends on your settings, but that's okay.
In case, if you
Yes,
have a Google
Google sign
account,
in.
please do sign in. Or you could create a free account. That's fine. No problem, no problem. So 3 minutes are okay. Okay, all right. While you're setting up, we could keep listening. And take up, we need to execute the installation lines now, right?
In this case, we don't have to. The installation lines are if you have installed Python using Anaconda in your screen, then you would need these installation commands to run and install the libraries NumPy, Pandas, Matplotlib. In Colab, you wouldn't need this now.
Excellent. There is a question in the chat that is Colab required, or if people, those who know their ways, can they work from the terminal as well? You're most welcome. Use any environment you're most comfortable with. We're very flexible with that. But if Colab is an option, you're most welcome. That helps keeps the troubleshooting steps simpler. All right. Let's see. I hope most of us are done with the setup. Anybody facing difficulties?
If you're done setup, you will end up with this screen. Your browser page should look like this. If you are facing difficulty, do let us know. Okay, that's good to know. Annajiat, you're muted. Sorry.
If anybody is facing difficulties and you'd like to go to a separate room to troubleshoot, you're also welcome. Just feel free to ask and write in the chat that you need help. All right, can we move to the next slide?
Right.
So this is our plan. First, we don't assume any prior background. We are not gonna be expert in programming or visualization in one day, but we'd like to get started. That's the spirit. So focus on basics. If you knew of Python already, please feel free to correct us and help us. Uh, and if you're new to it, we'll try to keep the Python per minimum so that we can get started. Okay, so there are some libraries, and we have chosen two of them to help us with the visualization, but there are several more. Let's move forward. All right, so we are going to need help sooner or later. So how do we seek help? We have multiple sources from where we could seek help. Of course, in this age, anybody would ask ChatGPT, Gemini, and other AI bot. But additionally, we have those documentations, the good old way, Python documentation. So Python is a programming language which helps us to get many things done. And they have their own Python documentation. This is the help for the programming for the Python part. Then we have the hitchhiker. So there are some resources listed here for the language itself, as well as the visualization library. And at the end, you see one word, help, and the parenthesis. This looks like a mathematical function. And it's exactly that. If you need help, you write help and execute that line. So the computer will show us options how we can get the help. And on the right-hand side, we have a hello world program. So we want to tell the whole world, I'm writing my first program. Okay, so if you're as good as recap, so it says print. So print means usually show on the screen, but it can also be saved in a file, sent over email. Destination could be anything, it could be database. But usually when you say print and followed by something, that thing gets displayed on screen. So it says print with a parenthesis like a function, and the functionality is show the message hello world to the string. So we have the double quote, which means show this exactly as a text. If you wanted to display numbers or value of a variable, then we'd use that. So would you like to show us how then we can get help and print the message?
So type help, HELP, followed by opening parenthesis and closing parenthesis, and press Shift Enter. Shift Enter, or you can also press this with your mouse pointer, this little triangle here. to execute this cell in your notebook, the Colab notebook that opened. So I'm going to press Shift Enter. It's going to take a little bit time the first time because there was something happening around your right hand side of your screen. It was showing connecting. So it connects to a runtime. That takes a few seconds, and you will end up with a executed output as this, asking for your input of what you want help with. So here you can type anything that you want help with, or you want to stop this at the moment. You can press this little square button at the top left, and it will stop asking for input. Okay, and the second part is to say hello world to the world. Here we would say hello world by printing hello world on the screen. That we do by typing the command print with an opening parenthesis, and inside double quote or a single quote, write whatever you want to write to print on the screen. So in this case, hello world, and close the parenthesis. So once done, you have to press Shift Enter to execute that cell. So I'm going to press Shift Enter to execute the cell. Alternatively, you can press this triangle next to that cell on the left hand side of your cell. So I'm going to press Shift Enter now, and it has given the output on the screen, hello world.
We're going to pause here a bit and let's wait for everyone to check whether we could run these two commands or at least one. So let's go through everyone and then we're going to do the call now. So please do the green tick so that we don't have to ask. Those who could solve it, please use a green tick. And we're going to follow up with others if you are facing any difficulties. So Aviva, Dana, Lemay, Eleanor, Gudrun, sorry if I'm pronouncing the names not properly, Hannah, Peter, Peter, you got that tick, sorry, Howard, George, Katie, Kumari Soti, Nisha, Sahel, Lukman, Charlotte, Jiang, Grunder. So if you're facing any difficulties, please let us know. If you're getting it done, very good. I hope everyone is being able to execute both of these commands. Things do happen. Things do happen. Errors do happen. So it's completely okay if you're facing challenges. Feel free to ask. No problem with that. Sometimes when we have explanation, I ran commands. I ran into a situation once. Whatever command I'm giving is not working. And if just after refreshing, reloading the page, everything started working. And in a last situation, restarting the computer solved the problem. So sometimes there is no explanation. So there are some intermittent errors sometimes. So things can happen. Or there could be a typing mistake because these are programming languages. Sometimes they're case sensitive. Sometimes they're sensitive to space. You put extra space, it doesn't work. Even one dot, one semicolon could make a difference. So it's very important that we type exactly as it is. Yes, we do have some flexibilities, but following the commands exactly as is will help us avoid most errors. All right, so we have received feedback from most people. And yes, your Zoom version might be different. You might not have a green tick option, or you might not be able to find it. Feel free to write in Zoom chat as well, like this. Okay, so for example, you could just say done in the chat. So feel free, whatever works for you. If you'd like to unmute and say that's completely fine. If you'd like to type in chat, if you use reaction, completely fine. Okay, excellent. So let's move forward a bit. Yes, variables. What are variables? So all of us that may have done some maths in schools and colleges or universities. If you're into social science or working with any data set, every column may be identified as a variable, right? So here in programming language, here a variable is uh, somewhat like a container for some value. So on the first line, we see text and then one equal sign, learning Python. So what it means, the thing on the right hand side is going to be uh, assumed as a value. It's like saving that value to a variable. We are tying the value to a variable called text. So anytime we say text to a computer, and it's gonna show its value, what it contains, which is learning Python. On the second line, we have another variable called number, and the value seems to be 42. On the third line, it's not whole number like the second line. It's not an integer, it's a floating point number, it's a fraction. So pi underscore value, that's one name. So here we see we can inside our names, we could use underscore as a word separator. It helps in readability. So the value seems to be the value of pi, the approximate value of pi. So on next three lines, we see type text, type number, and type pi value. So we are telling to show what type of data it is. And if you use the command print text, print number, print pi value, is going to show us value of those variable. So in any task, in any bigger task, when you're going to plot something, there going to be one or more variable whose value we are going to change over time. Some of the value will get calculated. So let's try this much in the Google Colab first. Again, if anybody joined later, I'm going to share the link to the slide in the chat. So please feel free to look up there. Okay, so let's declare the variables. And the values. Is the screen font size okay? Should we zoom a bit? Should we increase the font size, text size? Is that okay, everyone?
All right, so we write the variable name first, text, and that equals, and you start with a double quote or a single quote to indicate you're going to type something that you want to be as it is, to be stored exactly as a string type. And then you're going to write in the inside the double quote. So let me put the double quote enclosed, and then within these two double quotes you type the text that you want to print. In this case we're going to type learning Python. So learning Python was the text. And press enter and go to the go to the next line. It's a new line where you can type something more, some more commands. So here we're going to type another variable as in our slide. Uh, we have number and it's to be 42. Notice I put a space in between. This is okay. The space in between the variable name and the value is all right. Okay. I already executed it. I pressed Shift Enter. That means the cell got executed. Now, we'd like to write the next value as well because we want to show you something. So next value was that pi. So we say pi equals 3.3.14. And now I'm going to execute the cell by pressing Shift Enter. Now, notice that when I press Shift Enter, it executes the cell and moves on to a new cell. You can alternatively press Control Enter. In that case, it will execute the cell but will not create or move on to the next new cell. So for us, we want to write more code. So I'm recommending pressing Shift Enter, but you can execute only one cell and not move away from that cell by pressing Control Enter. If you're in Mac, the key combination may be different. It might be Command Enter. So, and alternatively, you can always press this triangle button. All right. So now we have executed 3 lines of code with 3 variables having 3 different types of values stored in them. Now we want to see their type. What type of data got stored in each of these variable. So we type type, then opening parenthesis, and type the name of the variable, text, and press Shift Enter. It says str. Str stands for string and a collection of letters and numbers. A collection of characters would be called a string. So this is a string data type. We did not explicitly say what data type this is. It was automatically, implicitly implied. All right, then let's see the type of number variable. Once again, I'll press Shift Enter to execute, and it says it's an int type, which is an integer. And next, we try to find the type of pi variable. It says it's a float type. So this is a way we can assign variables values. All right. Now, if you want to use the variable, the one of the simple command that we already have learned is the print command. We're going to print the value of one of the variables. In this case, let's print text, the value stored at the text variable. And let's press Shift Enter to execute. And here you see it printed the value stored in that variable. Now, notice that when I wrote text inside the print function, I did not use the double quotes. Previously, when we used the print function, we used the double quotes to indicate what to print. But this time, we don't want it to print the word text. Instead, we want it to print learning Python, the text that is stored in the variable text. So similarly, if we print number, it will print the number that is stored in the variable number. All right, we'll wait a few seconds to let everyone catch up. Let us know if you have difficulty to follow the assigning of variables.
Let's wait a few minutes for confirmation if there is any question anybody would like to ask. If you'd like us to repeat anything, please do ask. So let's we wait 30 seconds for potential questions. All right, so let's have a look at this slide again. Okay. So on the right-hand side, if you look up, comments in Python. So it's like a way to remark. So programs, all visualization, all the assumptions, unit, any consideration, these things are gonna be there for a long, long time. So what gets written for one day may survive decades. So it's very important that we keep comments or remarks as self-documentation. So what formula was used, what unit was used, why certain strategy was used for programming, for visualization. That is very important because even though everything is crystal clear to us, over time, after a few months, after a year, we may not remember much. So it's very important to keep documenting. And on top of that, we could also use this. So what does it look like? We're talking about the green lines on the upper right corner. So we use it to write helpful notes. Then we could use to quickly deactivate any line. Deactivate any line that is we add this hash or the number sign in front of any line, computer will treat that as a command. So it will not execute that line. So if you see the last two lines, the difference between the last two lines, the last line gets printed, but not the second last line. So commands are very powerful too. There are several kinds of commands, single line command, multi-line command. So, but that's a very useful thing. If we look at right below that, there's a function. So in the mathematics, we have done functions. So you see add function. So you chose the name in a way that is self-descriptive. And we are passing in the parentheses, there are two things, A and B. So we are passing two parameters to work on. And the result is going to be the summation of both, and we return the result. So you see, the first line starts from the left, but the second and third line is a bit shifted to the right. So that's how you define the block. And last two lines are the usage of the function. So, and printing. So that will be in different locations. So let's, before going to the call again, from the left-hand side, we see operators. So we heard about Bodmer's rule, but in programming, they have a more extended rule. So the arithmetic division power, the two stars to asterisk that we see, has a special meaning. It means a power to the power. We have logical operators, so different mathematical and logical operations are possible. Okay, let's try some of these in the Colab.
All right. So we're
Maybe,
going to type a function. Is it?
please go ahead. Thank you.
Okay. So according to our slide, we were going to type, write a function to add two numbers. So how do we write the function to add two numbers? Is that we make a function definition. We write it by saying def and a space, and then the function name, add, and then the um, parameters that we want to take into that function from outside. So A and B we're going to take as input to this function, and we're going to write a short comment as add two numbers. This part of the line will not be executed. And then we move on to the next line by pressing enter. And here we have to indent to indicate that we are inside the function block. We're going to write code for what the function is going to do when it will be called. So I have pressed two space bars, two spaces. You can press four spaces. What's important is to keep it consistent. So two spaces and four spaces are common. We're going to do two space here and then write the next part, the next code, which is to be inside this function block. So what are we going to do? We're going to put a variable total equals a plus b. So this is going to do the arithmetic operation of addition, and the result is going to be stored in the variable called total. And then we need to return that value, the summation, back to where the function was called. So we return by mentioning the word return and then what we want to return, the value stored at total variable. Okay, now we press enter again, and our function definition is over. Now we want to write a code to call this function. We have to be outside this function block. So we have to get out of that indent. I have pressed one back button to go all the way back to the same level as the D D letter here. So that's the beginning of the line, and from there we can start writing the next set of code. I'm going to put an additional line so that it's readable. And then we're going to write the next part of the code. Next, what we're
Can
going
we
to do,
do
we're
the
going to
next part in a separate cell?
in a separate cell. All right. So in this case, shift enter to execute this cell. This executes the function definition, and now we can use that as many times as we want. So how do we print? How do we add the two numbers? We can call the function by its name and pass it two parameters. Let's say 5 and 10, and press shift enter. It adds the two numbers and returns the value. Um, in this case, it prints whatever value it got. Now, if we want to use that value in our program later on, we would like to store it somewhere. So let's say a variable sum is where we will store the addition. So add 5 and 10, and we press shift enter again. Notice that no output was shown because the variable is the result of the addition is now stored in the variable, which will not be printed on its own. Now we can use this variable by in any other place where we want. In this case, we want to print it, so we use our print function to print this variable called sum, and let's see what it says. 15. So now we know that we can make a function to do certain function and use its value later on in the program. Use the result of that function later on in the program. Okay. So we will wait a few seconds or a minute to let everyone catch up.
The intended way that we'd like to go forward is we try something, you try side by side, or try during the time given. Of course, everybody's learning style is different. Maybe you are watching this on a phone, or you'd like to try this later. We welcome everyone. So we have shared everything with you, the slide, the code, everything is there. If you'd like to just watch and try these things later, that's fine as well. But it may be helpful to try a few things now if possible. And the idea is to run into errors. And if you run into errors, you could ask questions and try to solve that. So that might be helpful. Okay, so please try and let us know whether you succeeded or facing difficulties. Excellent. In the meantime, would you like to share the link to the Koala file as well in the chat?
Okay.
Or in the first break, whenever you're comfortable.
Yes. This is the link to the collab file where I'm writing the code. And
do we have access permissions?
okay, just a moment. So anyone with the link? I'm pasting it again. Okay, so if you go into this link, you will be able to view whatever code I have typed in, including the executed output.
And we're starting a bit slow, so might be getting bored a bit, but we'll soon jump into gradually more advanced topics. So if you'd like us to speed up or go slower, please do let us know anytime. Okay, I hope you're being able to do that. And again, any difficulties, feel free to ask and we will retry again, no problem. And of course, the recording is there. You could play back. It may take some time for the recording to be available on YouTube or other mediums. So let's go forward then. So, Intekhabul, would you like to discuss the libraries and
Yes. So
show us how to look at the data
now we are
and do the
familiar with
visualize?
functions. Yes, thank you, Annajiat. Okay, now we are familiar with functions. So there are functions which are already available to you as soon as you install Python or you have your Google Colab ready. And the ones that are available with the Python installation are mostly the the built-in functions, and there are other functions that you write, your custom functions, and there are functions that you can use which have been prepared by other programmers. So the programmers can make available their code, or you can make available your code to others in something called libraries. Libraries are a collection of functions and data structures, and they provide you with a code implementation where you don't have to rewrite the entire logic again. Instead, you will use the functions and the data structures they have created to do more with those functions and data structures. So we are going to use a few libraries today to do our data visualization, and that would be uh, pandas, data frames, and we're also going to use matplotlib and plotline, plot9 libraries. So the libraries we include in our program by writing the word import. So in this case, we're going to import the pandas library, and we can give it an alias so that we don't have to always refer to it by full name. Instead, we can refer to it by a short name. And the way we use the library is we refer to it by its alias or the full name dot the function that we're going to use. In this case, read CSV is a function that's available in this library, which reads from a CSV file. One of the data files that I think one of the data files is a CSV type, and the other data type is a text file. So a CSV file is the one that we're going to read. CSV stands for comma separated values, and comma separated values have values separated by commas. uh, those values are indicating columns, and one line of that uh, file is the row of data. So that's how a comma separated value file is organized. And we'll get to see, we'll open and see our surveys.csv file in a minute. Um, but before that, it's important that we understand that we're going to use the pandas library to read the file, the data contained in the file that we have downloaded, and then we're going to use what we read from that file. So to use what we read from the file, after this read function has executed, it will attempt to give you the uh, the data from the entire file. And the way we want to do is we want to use that data. And so to use that data later on in our code, we want to store it in a variable. So here surveys is a variable equals the way we call the library function, and then the path and name of the file. So let's try importing our file. First of all, we need to have the file here in Colab. So right now, if you press this folder button, there will be nothing but just sample data, or you may have nothing here. And you need to put your file over here. You can make a new folder called data. I'll show that again. I right clicked on this empty space, then pressed new file, and it created something like this. Uh, Sorry, I did not create a new file. I created a new folder. New folder, and it shows a folder sign and says untitled folder. We give it the title data. In this case, I already have it. It's going to complain if I'm going to do second time. If you have named it something else, you can right click on it or press this uh, three dots and rename the folder. So that in case you have named it anything other than data. Okay. All right. If you ended up as I am seeing now, by any chance, to go back to the place where you are, you can go to this content folder, and then whatever was inside the content folder was the one we were looking at. So you will go to the content folder and then create the data folder. So tap right click on content folder, then new folder. Okay, and then type in the name. I'm going to give it a different name this time, but please type only data. And then you right click on the data folder and click upload. Once you click upload, it's going to show ask you the location
of the file. So you will select from your file browser the file that you want to upload and put it here. You press the OK button or Open button, and the file will show up here. Alternatively, we can directly download the file into this data folder using a command called wget. Now, to write this command, you have to put an exclamation mark and then wget dash o, capital O, and you say the output file as content slash data slash um, survey.csv, followed by the link that was provided. So let me check the link. Okay, surveys.csv. The link to surveys.csv, I'm placing it in chat again. And come back to the execution cell and type surveys. I pasted the link by pressing Ctrl V. Okay, and then we execute the cell, and you'll get a bunch of output. And once it's done, see that the data file, that CSV file, is now inside our data folder. Okay, inside our data folder or data directory. So it's important that you have reached till this much, because we're going to utilize this CSV file in the following codes in the next 2 hours. So it's important that we are all on this part. So those who are trying along, please let us know if you're facing any difficulty trying to put the data file in the data folder. I will paste the command to directly put it in the data folder. Okay. All right. So would like some indicator that you could follow. You can write done or put a check mark, right? All right, thank you. So let's move on. So to close this section of your screen covering a big huge part, you press the cross button or you press this blue folder button and it goes away. I had to click twice. Okay. Okay, so going back to our code, we are going to import pandas library. So import pandas. I'm going to give it an alias called pd, and with let me execute it in a separate cell. So shift enter to execute. And now I'm going to write the next line where we're going to store it in a surveys variable, and assign it the value read from the read CSV function. So we call the read CSV function from the pandas library by calling the reference dot read underscore CSV function. And since it's a function, you will open the parenthesis and you will close it. It may be a good idea to close it and start typing from within the enclosed parenthesis. And here, as a parameter, you will send the path of the uh, data file. So in our case, the data file is now in content. Uh, if you have forgotten how it is, you can see content, data, surveys. So slash content, that's from the root, then slash data, slash surveys, surveys, dot CSV, and press shift enter. Now the data is uh, assumed to be stored in this variable. We want to peek, it may be a lot of data. We want to peek into that and see how the data was loaded and what data was loaded. If you want to peek into that, we have a few functions available to us. Surveys.head, which means this pandas data frame that it got. Yeah, since I'm saying data frame, we would also like to see the type. Yes, let's okay. We will check the type. First, let's peek into the data that's stored there. So surveys.head. Surveys.head. And it's a function, so open and close parentheses and enter, shift enter, and you get a peek into the first few lines of data that was retrieved from that CSV file. Now, notice it's only 5 lines here. If you want more lines, you can mention in this parenthesis how many more lines you want to show. Here, how many lines, by lines I mean number of rows you want to show here. So by default, it's showing me only 5 rows of data. This is only just peeking into the file, but I'm sorry, the data frame variable. Now the data frame variable has the entire content that was retrieved from the service.csv file. We will see how we can confirm that how much it has retrieved. For now, we are checking if the data that we want is the way that we want. So here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 9 columns of data, and the first few lines indicate the first few rows of data. So here, the first value in the line separated by this empty space is the record ID, and the next value corresponds to the month, day, year, then the plot ID, and then species, then the species, their sex, then hindfoot length, and weight. Now, this data that we loaded from is a data of four-legged animals in a particular region, four-legged animals, and the study was on the species that are four-legged animals and over several years of study. So it's recorded with the date of the study. It's given a plot ID, and the species are given some ID when they were detected in that region, and their gender, and then their hind foot length. So the hind foot length was recorded, and their weight was also supposed to be recorded. In some cases, the weight value was not recorded. Okay, and you will come across data like this, NaN or NONE, none. They indicate that the value there is not recorded, it's empty. Okay, so one way is service.head. We want to see the bottom few lines. So the way we do it is again call the data frame variable dot tail and open and close parentheses, shift enter, and you get to see the last few lines. In my case, it's showing only 5 lines. The bottom 5 lines that was retrieved from our data file, and you see the value to be as it's shown. Okay, here we can see some values of weight were also recorded. Okay, so here we can see the number. This number is the row number that pandas, the data frame has in this variable, and this one is the record ID from the file. So these many rows we have retrieved from that file. In this case, 35,548. Okay, so service.head is to retrieve from the top of the file, just to have a peek at the top of the file, and service.tail is to have a peek at the bottom of that file. Okay. All right. So I talked about data frame. Data frame is the data type that is provided by pandas. Let's see type of our service variable. Service variable. Shift enter. And it gives you a lot of information in this case, but this is what we are looking for. It's a pandas core frame data frame type variable. So data frame is the data structure that it has determined from the function call. Yes, the function call was read CSV. Okay. All right. From this point on, I'll be continuing uh, without waiting. But if you are facing difficulty, You can always speak up, interrupting me. That's all right. You can type in the chat. That is also all right. Anyhow, you need to get my attention or Annajiat's attention to get some help. We'll be happy to uh, extend our help. Okay. So, all right. There are a few useful attributes and methods that you can use. I'm going to skip that part and move on to the next part where we're going to visualize the data. So now we have a data frame full of data that was retrieved from the data file that we downloaded a while ago. Okay. And now we're going to visualize the data that we have. Um, so let's start with a bar chart on the species count. And the way we're going to go about is species count as a variable and assign it the um, count that we would get from that data frame. And we're going to group it by the species. So we're going to get per species count. So the way we're going to write it is species count is the variable equal to pandas pd dot, we're going to group by okay, I've made a mistake here. And it's not pd, we already have the data frame, so surface is the data frame dot group by, and here we pass what we want. We want to group by species ID. So let's look back at our data. We're going to group by our species ID and get that count. So species, oh, in this case, you have to use the single or double quote. I will use the single quote here. Species dot underscore ID, and spelling is okay. Okay, and that we want to count. What do we want to count? Uh, the record ID too. So we are going to count how many record IDs are there for that species. So how we write it? We write square bracket and write the name of the column that we want to count. Here we want to count record ID. So record ID. All right. Count close parenthesis. So now if we run this, it's going to store the count in the species count variable. So shift enter to execute this cell, and let's see what we got. We can print species count, or we can plot the count in a graph. So to plot the to plot it, we can directly use the plot function in the surveys in the provided by the pandas library. So the species count dot plot should do it. And how we want to plot it? We want a bar type of graph. So we say kind equals bar. It will plot a bar chart and press Shift Enter. We have a bar chart. I will close this. Okay. We have a bar chart that shows the count of each species in this chart. Okay. So here we have our first visualization of the data that we have. Next, let's plot another uh, bar chart with the count of sex. So go to a new cell and surveys. Equal to surveys dot. We want to group by here with the column sex, and then we're going to count the record ID. So we'll write it the way we wrote before. So group by with column. This may be important. The spelling may be, yes, it's all small letters. So yeah, all small letters. And then we're going to count the record ID. That also in quotes. Record ID, close quote, close square brackets, dot. Now we run this cell, Shift Enter, and now we're going to plot the same way that we had done previously. Call the plot function and put the type as bar. So surveys, let's go text dot plot find equals bar. Shift Enter. You see it has now given us female and male count in total. So now we have plotted two bar charts. Those who are following along, if you're facing any difficulty, do let us know. Let's see something. Okay, is there a keyboard shortcut? Okay. Thank you everyone for joining in to help each other. That's the spirit. Okay, do we have more question? All right. Okay, Eleanor says, my plot isn't working. No, you do not need to import matplotlib yet. Your pandas should be able to do the job for you now. Okay. If yours is not working, we can have a quick look at your code. Would you like to share your screen? Okay, there could be several reasons. You may have missed executing the import cell, this cell, import pandas as PD. I'm not sure, but if you're facing an error, the error should indicate what to look for. So, okay, it's working now. Okay, if you face an error, would like to know what error you're looking at, and would like to learn from that how to look into errors and how to go about resolving them. Okay, in your case, you had to restart your Python kernel. Okay. Okay. So since we have done our first two plots, we will take a 5-minute break and come back and do, okay, let's make it a 10-minute break, and we'll come back and do a little more deep plotting. Yes, more. This time we're going to use a different library called Plot9, and we'll see how we can manipulate our data visualizations. So, okay, 10-minute break from now. Let's get back and all right. So we know about pandas, and we have used the pandas library to plot two bar charts. Now we are going to do a little more sophisticated visualization. In this case, we're going to use another library called Plot9, but we're still going to use pandas because we're going to use the data frames. So going back to our code, we already had imported the pandas library. We don't have to import again, but this time we're going to import Plot9. Import Plot9. Nice. Okay. Enter. Now with Plot9, we're going to use the same service library, but let's reload our file anyway. Let's call it surveys underscore complete, another variable, equals to pandas data frame dot read csv and the name of path and the name. So content slash data slash surveys dot csv, close quote, close parenthesis, shift enter to execute. Now our surveys complete variable has the data loaded from the file surveys.csv. Okay, now there's something we want to do. Remember, let's peek into the data again. Surface underscore complete dot head. This time I'm going to print 10 rows. So I'll pass 10 as a parameter into the head function. Shift enter. It now shows me 10 lines, 10 rows of data. Here we want to remove all the empty or the null value or invalid values here. So the way to do it, Panda gives us a function to remove these nan or none. Pandas gives us a function called drop na. We're going to make use of that, and let's save it back into the same variable. So surveys underscore complete equals same surveys underscore complete dot drop na. It's a function, so we need the enclosing parentheses. Okay, so here what I did was I'm going to drop all the invalid nan or none from our data frame and then store that back into the data frame with the same name, so it gets overwritten. Let's do a shift enter. Okay, now we're going to plot. If you're wondering how it may look like, let's peek into the head again. Surveys underscore complete dot head 10. Now I wrote that same code again here. You could run this cell again and it would show you, give you the recent execution. So you can either do that or write a new line of code and shift enter. And it removed all the data that had those null values. So now our data starts from record number 63. So record ID 63, row number 62. Previous records all had those invalid values, so we're not going to consider those. Those rows were removed from our data frame. Now we're going to work on the data that we have, where all the fields are filled in the proper way. So now we're going to use the plot9. Yes, first thing first, we need to import, which I had already done. You have to run this code, import plot9 as p9. This p9 is optional, as p9 is optional. It's only to give it an alias so that we don't have to type the whole word to refer to that library. Okay, so I'm going to plot this entire thing. So since we're going to write a lot, okay, let me start with p9. p9.ggplot. It stands for grammar of graphics, plot, then function call, open parenthesis, and you pass the data that you want to work on. So data equals to our surveys complete data frame. So surveys complete, and then you place a comma and put the next parameter into it, just like you had done for sending two parameters for addition. So here we're going to put another parameter called mapping. Now we are saying the word mapping because the um, in our case it's only two, but if you have more and you're not supplying all of them in order, then you have to name the parameter that you're passing. So in this case we are naming it just in case that uh, function ever gets updated, our program doesn't crash. So we're passing value to mapping, and what we're going to map here, we're going to map the weight with hind foot. The weight, sorry, hind foot length. We're going to put hind foot on the y-axis and weight on the x-axis, and a plot um, a point graph. Slash what happened? Oh, I moved it up and down. Okay. Okay, what I did was mistakenly I pressed the move cell down button. So my cell went down and the bottom cell went up. Then I pressed the up button and it went up. All right. So I'm back to where we were. Mapping P9 dot um, AES. And here we're going to say what we want on x-axis is the weight, and on the y-axis hind foot length. I'm going to copy it and paste it here. So copied with Control C after selecting the text, and then pasted with Control V and close the parenthesis. Here, notice that this parenthesis was closed. We need to close the first parenthesis also, because we're done for this line. And then we're going to say this is what the data will plot on the x and y axis. Now we're going to tell it what type of graph do we want. Okay, I pressed the shift enter button. It plotted nothing, but it says weight on the x-axis and hind foot length on the y-axis. So that much information it got. Now we're going to write even more to it. So we can change line, go to the next line, make a small indentation and put a plus sign and say it that you want a geometrical point plotting. So GEOM underscore point. We'll use this function provided by plot9. Okay, now it complains here with a red mark. It's because it can't understand that it has to execute these two lines as a single command. So we're going to put a bracket to enclose the whole thing. So at the beginning of the first line in this cell, we'll put a bracket, and at the end of this line, we're going to put a bracket. I'm going to put it even at the end so we can keep track of it. So here These two lines will be now considered one single command, and we execute it, shift enter, and this is the plot we have got. Now, what did we do? Okay, we used a function called grammar of graphics plot, ggplot, provided by the plot9 library. There we told it that we want to work on the surveys underscore complete data frame and to map our weight and hind foot length to x and y axis respectively, and then we're telling it to plot a geometrical point uh, plotting. So after we execute, we get a plot of a plot that looks like this. So lots of points. Now here it's difficult to understand the distribution or how it's um, to make out from it any meaningful thing. Well, of course, we can make out some meaningful things out of it, but to make it more visually informative, we can do few more things on this. Let's add colors into it. So I'm going to copy that previous part because we will need the same. I had copied the previous cell to this new cell, and then we're going to add colors. So yeah, we're going to add colors where the graph is going to look something like this. So okay, so here what are we going to color? Our data is hind foot versus weight, yes, and let's color it with species ID. So we'll get to know how get an idea of how many species there. So how do? We have to add another parameter into this AES function, uh, saying that we should color the species ID, color the species ID column. Okay. Now you see it went too far to the right. That's okay, but for readability, we would like to bring it down to the next line. So after the comma, I'm going to give it to the next line by pressing an enter button. So that way it indicates that it's still in the same code. Okay, same line. Okay. Okay, so we are still going to do the geometrical point. Let's plot this. Okay, we got a graph that looks like this. How about adding some transparent effects? Uh, so the concentrations would be darker and the um, sparse parts would be uh, more light. The way we do that is we write alpha and provide it a value between 1 and 0. So if we put 1, it's the same. If we put 0, it's nothing because it's completely transparent. And we're going to say that, okay, make it only 10%. Yeah, 0.10. Make it only 10% opaque. So that's 90% transparent. Shift enter. We plot it. Now we have an idea of where the concentration is. Okay. For each species, our same graph with a different visual. Okay. Now notice that the x-axis is weight. Let's change it and add a unit to it in grams or kilograms. So to add a weight, we need to add into this plot9. So p9 dot label, x-axis label, so xlab, and type what we want to show, weight in grams. Okay. So shift enter. All right. So it shows weight in grams as the label for x-axis. If you want to change the y-axis, you add another one, p9 dot y label, y lab, and say hindfoot length. And this may be centimeters. Okay. Shift enter. Okay. So okay. What does AES refer to? Thanks for answering that. Aesthetic mapping. Okay. All right. So now you all know how to change the label of the axis. Okay. Now let's try to change the scale of the graph. Let's add some logarithmic scale into the x-axis. So let's copy the previous code, paste it into a new cell. Okay. Okay. So if we add a logarithmic scale, we'll get to see something like this because the concentration here is too much. We'd like to see that also. Okay. So here we're going to keep weight in grams. Okay. So we add a scale to the x-axis. So p9 dot scale to the x-axis. Yes, this is the function. Okay, so plot9 gives a function to scale the x-axis in the logarithmic scale. So we are using log to the base 10 here. All right. And if we run it, um, okay, so we have got a plot in the logarithmic scale for the x-axis, so for the weight axis. Now, these are one of the functions that you can use to change the scale of your axis. And the list of functions that you can use in a library is in its documentation. And of course, you can use the thing that you have learned at the beginning called help. Help, if I write P9, it will refer to the plot9 library and it will show its whole help. You don't want to run this now. If you want particular help with particular functions, or you want to refer to the whole documentation, you can try typing help over that. Okay. All right, there is something more that we can do in this. A little more editing the looks. Okay, so let's add a background theme. You see the background right now is in a way we don't want. Okay, let's make it a black and white background only, no gray. So we say p9 dot theme black and white. So this is going to change the background into black and white with grayish marker. So, and there's one more thing that we do. Text size we can increase. No need. And you see the difference. The background has changed now. So we modified some of the looks. Once again, the number of functions it makes available to you is pretty huge. So you can do, you can of course search in the documentation to what you might need for your case. Okay. All right, let's move on. Okay, we're going to plot the graph, box graphs. Okay, so we're going to do some box plots on the data species ID and weight. So, okay, let's pick that data again. Surface dot underscore complete dot head 10 lines. It's 10 Pythons or nothing. Okay. So, right. So let's plot against, let's plot the box plot against the species ID and the weight. Okay. So the way we do that is again, well, in plot9, since you're going to use a lot of those plus addition of plot properties, I would suggest using putting the putting the parentheses first and then start typing. So p9 dot ggplot and data is our old surveys dot underscore complete, and mapping would be b9 dot as. We say the x-axis would be species this time. X-axis would be species D, and y-axis B. Okay, so x-axis is species, y-axis weight. We have to close another bracket. Move on to the next line. Let me put a few indentation, and then we add box plot type. So b9 dot box geometric. Okay. Well, this was not necessary. You can leave it, leave that space. It wouldn't cause any harm. Now I'm going to press Shift Enter to run. Shift Enter. We have got a plot, a box plot of the data. Okay. So weight over species, all right. Now, let's add some color to it. Well, first of all, let's add some jitter to it. Yes, of all the plots. The way we'll do that, we're going to add into this code. So we'll copy it, paste it, and here we're going to say jitter to p9 dot geometric. Okay, and if we run this code, we have got an error. Plot9 has no attribute. All right, you see the error. I have made a typo. It should be geometric, Geom, I don't, P. So M. Let's run it. Okay, there we are. We have some plots. Okay, but it's pretty messed up. So let's change colors or add some yeah, let's add some. Okay, I'll keep it this way. Let's add some transparency into this. Alpha equals 20%, so 0.20, and use alpha also around 20%, 0.20. Shift Enter. Okay, now we have a better view of our data in the box plot. Okay, so here you see the transparency also played into it. Okay. All right, so until box plot, what questions do you have? All right. Could you follow until this box plotting? We're going to go. We're going to go into another library called matplotlib, and we're nearly done with plot 9. Plot 9 helps to plot your graph rather easily compared to the matplotlib library. Now, matplotlib is more robust. The code for 5 seconds. So if I zoom out, is it okay, the size? Okay. Okay, so the matplotlib library gives you a robust control of your graphs, but it can become overwhelming if you're just starting with plotting graphs. So, it might be easier to get started with um, plot 9 and later on shift or as necessary move on to matplotlib, and they can be interchanged. I'm not sure if it's the other way, but you can convert from plot9 to matplotlib. Okay, Jessica has uh, given us a code. Is there something you're asking? Okay. Okay, I got it. You answered to Aviva. Okay. So, before we move on, there's one last thing. How do we do line plotting? Show it quickly. Line plotting. Let's see. Okay. So here we're going to do a line plot with species against the with the count of species against every year. So we're going to use the P9 in this case, and then we'll move on to matplotlib. Okay. There's a question here. Tang, you're asking, does the order of the subsequent plus options matter? Yes, it does matter. It will give you the layer. So if you put the box later, then the box will be drawn later, so above the dots. Yes, it does matter. Okay, so let's get into the code. So we're going to do yearly count. So yearly count equals our data frame was surveys underscore complete dot we're going to group by for every year. We're going to take the species count. So for every year we're going to take put in square bracket, since we're going to group by two columns, first by every year and then by the number of species ID. Okay, and group by is over, and then we want to plot species. To count the number of species dot count. Okay, sorry, it's species ID. Species ID. Okay, and we execute. Now we have the count per year stored in this data frame, and from there we are going to plot. So we are going to use p9 again, p9.ggplot, p9.ggplot, and passing the data equal to yearly count. Okay. Then cell mapping equal to p instant x equal to year, and the y axis we want counts. Again, inputs count, and we want to color the species ID. Color the species ID. Okay, and we close one bracket, two brackets. Okay, now we got to, sorry, I pressed again the shift enter button. It tried to execute and paste an error, says incomplete input. Yes, I have not completed. We'll go to the next line. I'm going to add more to it. P9 dot geometric line. Okay, and keep it opaque. And now we got to close the last bracket. Okay, so now if we execute, I have reached an error with the data. Bad type of argument here. Here. Okay, this one is, we can tell this one is here, species ID. Okay, we got year, counts, species ID, this okay, let's print this yearly count, see what it shows. Yearly count dot species ID is also species ID. Should be count. Okay. This one needs to be changed. There is a mistake in here. We want to count and put it as species ID. How do I change this into counts or the name? Just a moment. Count function doesn't do. Species IDs. Okay. The count only returns the number. And then species. Okay. Okay, the error if here is that there are two fields with the same name. Now, we don't want this to be with the same name. We want it to be counts. But it didn't change. We wanted counts, it couldn't find the counts. That was the error. It's complaining. It's species ID. Okay. We got here, then species IDs. Yes, we are related to expected data frame or mapping. That is what we gave. Okay. All right. Would anybody be able to figure out how to name it? Okay. We have the problem here. Um, okay, let's do one thing. I'll take a 5-minute break. I'll figure this out. And after the break, we'll plot this. We've already written the code to generate the line plot. I'll tell you the fix after I get it done, and then we'll move on to the next library. So 5 minutes break. When you're back, I'll figure this out. Okay. All right. Um, there is something that I missed out after grouping. We have to reset the index uh, uh, and give it a name. That is something I missed out, for which it was giving the error. So here, to reset the index, I call the data frame dot reset index and then give it a name. So you have to run this immediately after the grouping, uh, uh, immediately after grouping that you do the count, and then when you reset, here's the difference. See, this was the output earlier. It didn't rename the counter, and after running the reset, now we have the counts variable. Okay, so now if we go over and run this code, we have the plotting uh, of line graphs. Okay, so we have the count of species over every year. But so this is how we plot the line graph. All right. Okay, thanks Alex for the direction. He's given me a private message to direct me through to which uh, where the error was. Okay, now moving on. Um, okay, Beth says, okay, show again. All right, I'll show you again and then. Okay, you've answered it. Yes, that was the only change. The change was here. I added an extra cell by pressing this code plus code button. When you hover over a cell bottom, you get a plus code button. I pressed that. It opened an empty cell between the two other cells. And then I started typing here. And here I typed this line of code. Sorry again. Okay, here I typed this line of code where I reset the index after we got the data frame after grouping by. Okay, so I hope that's clear, this mistake. Since we got the error, you see how did we go about resolving it? Python does give you some guides into what's wrong. So don't be afraid when you face error. Let's run this again. It's going to overwrite yearly count, and I'm going to generate that error again. Let's run it. It's a little sophisticated error than other simple error, but it still gives some guide into what's wrong. So here it says there's a type error. So, and it says it got year and species ID. It should also get a counts column, but it doesn't say about that. That gave an idea of there's something missing here. So when I looked into the data frame, I saw here there is not, the column name is not what we want. So then we went to figure out how we can resolve it, and then we came into this solution. If we reset index and give it a name while resetting, that name is then given to the column, and now our data frame is okay for plotting. All right. Okay, we will move on. There is one more thing in plot 9. You can facet wrap over your graphs. So uh, let's say you have the graph that you already have, and over that you also want to show uh, 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 the distribution of male and female. That also can be done. Those facets can be added into your graph. So all you have to do is add this facet wrap into it. So I'm not going to code that. Next, we move on to matplotlib. This is another library. As I was saying, that this library is more robust than plot9. Plot9 makes it easy for beginners, and of course they have functions for advanced users, but but for a beginner to begin with matplotlib may get overwhelming. So a recommendation would be to get started with plot9 and then move on to matplotlib for things that you are unable to do or face difficulty doing um, with plot9. Uh, from plot9, you can convert to matplotlib anytime. We can have a look at that also if time permits. So it's a new library. Yes, matplotlib. We need to import it. So we're going to import matplotlib, and in particular in there we're going to import the pyplot module. Okay, so we write it like this: matplotlib dot the module name pyplot as plt. So let's type in our code. All right, this error, let's rerun this. Error is gone. All right, so import matplotlib dot pyplot as plt, so that we don't have to write matplotlib.pyplot every time. Shift enter. Okay, matplotlib is now imported and ready to be used. Now we are going to type in moment. Okay, we take a variable called surveys equal to we read from file again. Read CSV 10, sorry, it's the root directory slash content slash data slash surveys dot csv close quote close parentheses and okay, let's run this. Then my plot, so 2 words, I'll separate it. My plot equal to surveys dot plot. What are we going to plot? Let's plot the hind length and the weight. Okay, sorry, plot the hind length, hind foot length. Okay, and we're going to pass on to it the scatter. So kind equals scatter. And we close the parenthesis. Okay. Now if we run, it plots you this graph. A scatter with weight on the y-axis this time, and the hind foot length on the x-axis. This was done using the matplotlib. We used this was not done with matplotlib. Implicitly, it's done with matplotlib. This our data frame, pandas data frame, implicitly uses inside the plot function the matplotlib. So here we have this scatter plot. Now we're going to do it with matplotlib. So here they have done that again with plot 9 and then converted into matplotlib. Okay, so let's make quickly that plot 9. Okay, import plot. No, we already have import. We don't need importing. Okay. What was my plot? My plot equal to p9 dot ggplot data equal to surface and mapping axis p9.as p9.as, where we say the x-axis would be the hind foot this time, hind foot length, y-axis would be the weight. Okay, close the two brackets, and then we add plus scatter plot, so p9 dot geometric point, and we close the bracket enclosing the whole p9 statement. Okay, and let's run it. It will now save it in my plot. Now we're going to draw it using PLT. So let's save it into another variable. My PLT version equals my plot dot draw. Okay, this one says name error, so my underscore plot, that's the name. We didn't have anything by this name, so it gave an error. It gives you an idea that there was a typo. Okay, so now my plot, execute. Okay. It says it has removed some values that were missing. All right. Now, since we didn't do the and removing after um, loading again from the file. Okay, it has rejected 4,811 rows of data, of invalid data. Okay, um, fine. Now let's provide the adaptation for matplotlib. So p9 underscore okay, we can say ax equals my, I'm going to use my BLT version dot axis. We're going to pass it first axis. Okay. Okay, press shift enter. By mistake, you can write it all together. My intention was to write all together. P9 underscore ax dot set x label. X label. Okay, again, I press shift enter. That was not my intention because the task is not over yet. Then p9 underscore ax dot set title. Give it a title. Scatterplot. Scatterplot. Friends. Close quote, then close parenthesis. Okay, and there is something we want to add. Okay, let's run this one now. Okay. We want to print the plot. Text character plot. Text. Now we say okay, this should have printed out. Okay, I'll have to check that. There is something that I need to show first. That is, how do you save all this plotting data before we end? In matplotlib, you can do plt.save figure, and it will save the file by the name that you give. And if you use the p9 library, then you use something that we're going to save in ours. Just a moment. it's not available. One moment, I'll find out. Wait, Annajiat, do you remember how we saved the P9 plot 9 graphs? Save figure. Save figures for matplotlib and says save fig itself. Okay, let's try it. Hmm. Save fig is not available. Not sure why it's not available here. Okay, I'll get back to you with this data, but before that, until now, what questions do you have? Because our time is also about to finish. We're also nearly done with plotting. Um, so what questions that you have regarding the plotting, visualizing your data using uh, plot 9, yeah, then we did direct pandas plot. Yes, how to visualize the last plot. I'm going to get back to that. But before we end, because people may need to go if we shoot over time, um, how do you plot? Okay, I'm going to give you the guide that we at the Carpentries have designed for this course, visualization. So everything that I did was the material from the Carpentries, data Carpentries material for visualization. It's available at this location. Okay. Yeah, I think you do my plot version. It shows you the plot. Should it? Okay, I would definitely would give that a try. Well, if we run it, thank you. So that was the missing part. All right. So here's the conversion from plot 9 to matplotlib plt. Okay, thank you.